Okay, so this is video 2, and we're still talking about probability. So I'm looking at the 2017 paper 2 question 1 here, and we are told when Connor rings Kira's house, the probability that Kira answers the phone is 1 over 5. Now again, I'll be putting up the question on Teams if you don't have access to the question, but that's what it starts with. So I would recommend to have the question open beside you if at all possible from your exam papers as you're watching this video. So, part A. Okay, so the first question is a very straightforward permutation question, really. Very similar to what we were talking about in class. So Connor rings Kira's house for 7 days consecutive. Find the probability that she will answer the phone on the 2nd, 4th, and 6th day. So this is just like your place when it comes to the last video when I was talking about it has to end with 0, or in class when we're talking about vowels and whatnot in different combinations. So what I would do for answering this question is I would set up my 7 positions, the 7 consecutive calls. I would then pick out where the 2nd, 4th, and 6th is. So the 2nd is here, and then this is the 4th, and this is the 6th, naturally. So that's the other days are there. First, just about writing them down. But on the 2nd, 4th, and 6th day, they want the phone to be answered, which means we should put in 1 over 5 into each of these particular positions, which means the remaining other days is when the phone is not answered. Well, if the phone is not answered, that is the opposite of answering the phone. So answering the phone, where we're told in the question, is the 1 over 5, which I have filled in into its required positions. To not answer is the opposite in probability, which is 1 minus the other. So that's what that will be, which gives us 4/5. Okay, and that's from junior cycle maths. So to not answer the phone is 4 over 5. And that will go into the other days, the 1st, the 3rd, the 5th, and the 7th days. We will put in 4 over 5. And then, just like in permutations, just as normal, they will multiply by each other, each of them. And you put that through your calculator to get your final solution. Now, it's I would always give this as a fraction, and in all answers, I would usually always give the fraction answer because it ends up being a recurring decimal, your answer. So I would give it in rational form. So that's what it is, a fraction. If you really want to write it as a decimal, to the nearest 5 decimal places, I've worked out to be 0.00328. But I would put down at least both. So again, just to go through it, on the 2nd, 4th, and 6th day, she answered the phone, so that's why I put in 1 over 5. On the remaining days, she did not answer the phone. To not answer the phone is 4 over 5. That was filled into the remaining days. Multiplying all these fractions together with the calculator gives you 256 over that. Okay, that's part A. Part B. So for part B, we're asked to find the probability that she will answer the phone on the 4th time on the 7th day. Now, there's a couple of English in this, and whenever you find that you're answering a probability question where there's no specific time needed, and what I mean by that is the only specific thing we know. So I'm just going to put my place values again, my placements. So 1, 2, 3, 4, 5, 6, 7. We only know that on the 7th day, the phone must be answered. Okay? The phone must be answered here. So that's 1 over 5. That has to happen. However, there is a number of ways that we can have these other days mixed out. It just has to be the 4th answer. We could have had up here the other 3 answers, and then this was the 4th. Or equally, we could have maybe 2 here and 1 here. There's quite a lot of different ways that you can permutate as to what happens if you're not answering the phone. And when you find yourself in that situation that you're not, let's say, for example, you're just not sure where to put in the rest of them, there is a nice formula on page 33 of the log tables, and we'll be discussing this in more detail in class, but it's called the binomial distribution rule. So it's on page 33. And I'll explain the formula now in the video. So page 33, we have n choose r by p to the power of r by q to the power of n minus r. Now, to explain what each part of the formula means, n is the number of trials or tests. So let's use hashtag tests or trials. So it's going to give the generic terms for the moment. R is the number of successes. So the required successes. That's maybe a better phrase to use. So the required successes or wins or good things. Then P is the probability of success. And Q is the probability of failure. Now, there's some of these you can get very quickly. The probability of success for our particular question is being the very first probability given. That will straight away be a 1 in 5. Basically, the phone is answered. That is a success. And naturally, the probability of failure straight away is a 4 in 5. The phone is not answered. What we need to try and work out is, based on this formula, what does n mean and what does r mean? So, we know for definite that the 7th day is answering. So I have to ignore that place. So I might even leave my pen on top of it, which means we've only got 6 trials to now test with, not 7, because I know on the 7th day I have to have an answered call, and it has to be the 4th call, but it has to be an answered call. So that means we've only got 6 trials to work with, so that has to be 6 for this particular question. And we now need to work out, well, how many successes. So this has to be the 4th call answer. So that's the 4th success, which means then, well, if the 4th success is here, there has to be 3 other successes, we'll say, or 3 other wins has to happen in these 6 places. So the required successes for these 6 positions has to be 3, because the 4th one is on the last day. Okay, so the reason why it's 6, not 7, it's 6, is because we've took one of the place values that on the 7th day there has to be an answered call. And the reason here why it's 3 and not 4 is because, well, we've had a success on the 7th day, and we need 4 successes altogether in this particular question. So if you read the question in your own time, you'll see what I mean by 4 successes the 4th time. So we've already had a success on the last day, which means we've only got 3 successes now left. Fitting this information quickly into the formula will look as follows. So we'll have 6 choose 3 multiplied by the probability of success, which is a 1 in 5 chance. That's 0.2 if you want to put it as a decimal. And that's going to be to the probability of 3. And then we're going to have the probability of failure, which is 4 over 5 from part 1 of the question, multiplied by n minus r, which will be 6 take away 3 in our case, which is also then means the power of 3. And if you look at the formula, it should even help you understand it even further, because this represents the total amount of times the phone is not answered, which has to be 3 out of the 6 situations. This represents the total number of times that the phone is answered. Well, if 3 of these is not answered, 3 of them is answered. And finally, this is all the ways that you can arrange this situation and this situation in these 6 spaces. I could put these 3 at the start, these 3 next. I could put 1 at the start, then the 3 fails, and then the 2 successes, etc. This represents how many ways can I arrange these 2 decimals or these 2 fractions in this situation. Okay. Now, using the calculator to get 6 choose 3 is the last step then. So I'm going to 6 choose 3 on my calculator. So the way I do that is 6, shift, the divide button, then NCR. Apologies, that's too low on the camera. I'll show it again. So 6, the shift button, then the divide button brings up the choose, NCR. So that brings up C in your calculator, and then 3, and you push equals. So 6 shift NCR 3, 6 choose 3. That brings up 20. Now I know you can't see that on the screen. Okay. The light may bring it up just to show it one last time. So again, I'm going 6 shift NCR 3 equals, and I'm getting 20 as my final solution. So for 6 choose 3, that's going to be 20. We're then going to have 0.2 to the power of 3 in my calculator. 0.2 to the power of 3 is 1 over 125. And then 4/5 or 0.8 to the power of 3. You can type in the fraction to the power of 3. It's just easier sometimes to type in the decimal, is a bit quicker. Is 64 over 125. But we have to make sure we don't forget something at the very end. This is just the first 6 places. So the number I'm calculating here is the number for these 6 places here. So I'm going to get that now. It should be 20 multiplied by 1 over 125 multiplied by 64 over 125. So this value here is 256 over 3125. So this number here is 256 over 3125. But we can't forget our last place. The success of being answered on the 7th day, which means this must be multiplied by the success of being answered on the 7th day. So all these 6 places mathematically is 256 over 3125 probability. We then multiply that by the 5th, which is success, to give us our final solution then as being 256 over 15625. And to a decimal, that is 0.0164. There are more decimal places, but that's rounded up to the nearest. Okay, in the next video, I will finish this question. That was just for parts A and part B.